Everybody, here is your bell ringer for the day, so please pause the video and let the kids complete the bell ringer. Alright, looking at the first one, it says graph the system, then check the system by solving algebraically. Solving algebraically just means use our methods that we just learned, so it'd be substitution, elimination. So we have to graph it and then use substitution or elimination. Okay? So remember first, if we're graphing, we got to solve for the y's. All right, we're going to change it to slope-intercept. So the x goes over, and we have this, and then you divide everything by a -4. And remember, since we're dividing everything by -4, we have to make that number in front of the x look like a slope. So -1/4 x. Right here, if we divide that, that would give us a -2. Okay, the next one, move the 2x over, and we get an 8y equals -2x minus 16. Divide everything by the 8 that's in front of the y, and then simplify. So then for the second one, we have y equals, make that number look like a slope, -1/4 x minus 2. And guess what? When we graph those, it's the same line, so you can think to yourself what the solution is going to be algebraically, okay, because you don't even need to do a whole lot before we graph it. Okay, so starting at -2, a -1/4, remember that is down 1 and right 4. You always go up or down for that top number and always go right for the bottom number. Okay, so down 1, right 4 gets me to here, and then here, and then draw a line between those points. Okay, and we don't really need to do the other line because it's the same thing. All right, so that would be the graph, and then to save yourself a little bit of time algebraically, you could really just change one of these negative and add them that way, and you would get 0 equals 0, which is infinite solutions. Okay, that would be a consistent and dependent system. All right, for the second one, scroll down a little bit. If we need more space, we just need to write equations for each of the lines here. So we have a line here, a line here, and a line here. It makes that triangle. We have to draw 3 equations for that. So the top one is the easiest. Okay, this one up here. That's just a y equals 2. And we can do the inequalities right away. Okay, so y equals 2 would be the line. But remember, we're shading in here. So if we're shading below y equals 2, that would mean it would be a less than or equal to, because it's a solid line and it's shading below. That's one of them. Okay, let's do the other ones. Now you can use the slope formula to find the slopes, or you can just kind of count. Okay, remember we can count. So we have this point up here, and we're going to that point there. So we are going down 1, 2, 3, 4 over 2. So if we're down 4 over 2, that slope would be a -2. Okay, so we have a -2x, because that's my slope. Look where we're hitting our y-intercept right here, and a -2. Oops, -2x. So -2 gets me that -2 as a y-intercept. And it's a solid line, so we know it's going to have the equal to, and it's shaded the way my arrows are pointing here, so it's shaded to the right. All right, so that means it's a greater than or equal to situation. That's that second line that we're looking at. All right, so let's look at the third line. Let's get this stuff out of the way here. Third line right here. Same kind of thing we did on the last one. Okay, let's look at our slope. All right, so if we started here, we would count 1, 2, 3, up 4. I'm right there, and over 4. You can see that your slope is just a 1. So that's a 1x. My y-intercept is a -2 again. So we're there, and it is going to be up, and it's just dash. So we have that line. Okay, we have a dashed line here, and it's going up. You got to imagine if this thing extended on like that, okay, it would be shading up here. That's the inside of that triangle, which is greater than. Okay, so those are our 3 inequalities for that system. So it's kind of working backwards from what we did before. Okay. okay? All right, the lesson for the day is this, okay? Introduction to matrix operations. So that would be addition and subtraction, and then multiplication as well. All right? Your test grades are in Power School, okay? And we will go over the test tomorrow since I'm not here today. All right, so we can go over the test tomorrow, and I will inform you guys of my Einstein's pupils wall back there, okay? It goes in conjunction with our test scores. So we're just going to jump right into the lesson, and there will be a brain break in there. We'll get done, and you guys will have plenty of time for homework. All right? So if you don't have that title written down, please do so. All right? So first of all, we got to kind of identify what a matrix is. Okay, so we're performing basic matrix operations. Introduction to matrices, right here. Okay, matrices is plural of matrix. All right, so a matrix is just a rectangular array of numbers. There's actually a movie called The Matrix. Hopefully some of you guys have seen it, but it's just a whole bunch of numbers. Like at the beginning of the movie, it's a bunch of green numbers going up and down on the screen. Those can be an example of a matrix, okay? So I have an example of a matrix right here. This was just a basic matrix here. And we're going to go over the way we read the size of a matrix, okay? Because it's not just, oh, it's a 6-number matrix. We got to read the size, okay? So the way we read the size is we first look at the number of rows, okay? And we can say that this is row 1, row 2, row 3. So we got 3 rows, all right? And then after that, we look at columns, okay? So this would be column 1, column 2. So we have a 3 by 2 matrix. Okay, when we're looking at the size, we don't really care about the numbers that are on the inside. We just care about how many rows we have and then how many columns we have, okay? So this would be a 3 by 2 matrix. When you guys start to work in your graphing calculators with matrices, which we may or may not do in here, you have to know the size. If you don't have the size correct, then it's not going to work in your calculator, okay? So looking at that, you need to have this written down in your notes somewhere, okay? You read it as rows by columns, okay? And it doesn't matter, like I said, it doesn't matter the numbers in here. You can just slap 6 numbers in a matrix like that, but you have to make sure there are 3 rows and 2 columns. When I read the size as rows by columns, that will be beneficial for when we get to multiplication at the second half of this lesson, okay? So, before we start adding and subtracting matrices, okay, I want you guys to look at these 2 matrices here and tell the other people at your table what the sizes of each of them are. Okay, go. Hopefully you said they were both 2 by 2. Okay, because we have 2 rows and we have 2 columns. So it's just a 2 by 2. All right. Another special word for something that it's like a 2 by 2 or a 3 by 3 or a 4 by 4, which we probably won't get that big. Oops, 4 by 4. These are called square matrices. Okay, so you think of a square, it's going to have the same side lengths all the way around. Okay, so it could be a 2 on one side and 2 on another side. So it's going to be the same side lengths all the way around. Same thing with matrices. You're going to have the same number of rows as you do columns. Okay, those are called square matrices. Right? So good information. Looking at these 2 matrices, hopefully you looked at the worksheet that I gave you guys on Friday. I told you to look at it quick before you left. It's not too difficult to add and subtract matrices, okay? First thing we have to look at is if the sizes match, okay? So with this one, we already said they're both 2 by 2s. The sizes match, so we are good. Then you can add them, all right? And addition and subtraction works the same way. Addition, you just add the corresponding pieces. So I'd add this 3 with that -1. And when I make my new matrix, it'll go in that same slot. Okay? 3 plus a -1 is 2. All right? And then we look at the next one. All right? So let's move these guys over here. Let's look at the 0 and the 4. 0 plus 4 is just 4. It goes in that corresponding slot. Next one, a -5 with a 2. -5 plus 2 is a -3. And then the last one, -1 plus 0 is -1. So we have a new 2 by 2 matrix after we added them together. Okay? And subtraction is just as crazy. All we got to do is subtract the same corresponding pieces. Okay? This operation here is kind of where I like to do the add a line, change a sign thing. I never really did that with my addition and subtraction, but it kind of is nice here because there are so many numbers over here. So rather than thinking of it 6 different times, you can kind of change everything once. So what I want to do is change that negative. I want to distribute that negative. I want to give the negative to everything in here and then turn it into addition, okay? So it will look like this. So add a line, change your signs. And I guess the 0, you don't need a negative in front of the 0. All right, so that changes positive, positive, negative. Now you're pretty much adding a negative, which is the same as subtraction, okay? That's the easiest way to do matrix subtraction rather than thinking about it 6 different times. So now we got 5 and a positive 4, okay? 9. See if you can finish the rest of that real quick. See if you can get it done before me. So 3 plus a -2. 1. -1 plus 0. -1. And then I have a -2 plus a 3. That's a +1. 4 plus 1. That's 5. 0 plus a -6. That's -6. So pretty crazy, right? Addition, subtraction, it's just as easy as addition, subtraction, just doing it more than once for each matrix, okay? And you can have a 1 by 1 matrix. It just doesn't happen very often in math because it's a pretty simple. It kind of defeats the purpose of doing matrix operations. Okay, so addition, subtraction. The next thing, just as crazy as addition, subtraction. Once you get to fractions like that 1/2, it's not bad, but people don't like fractions. We all know that already. Okay, so it's multiplying by a scalar. I've used that word in class before with the equations. Okay, when you scale an equation, you use a scalar. You just multiply that number all the way through. Okay, all the way through the equation. We do the same thing with a scalar in a matrix. Okay, so it's kind of like distributive property. I'm going to take this -2, and I am going to multiply everything in my matrix times the -2, which will give me a new matrix. Okay, so -2 times the 3. Oops, back up here. -2 times a 3, that is a -6. -2 times a 5, -10. -2 times a 6, -12. And -2 times a 10 is a -20. So that's your new matrix. Okay? If you haven't written this second one down, go ahead and do it. And then see if you can multiply that 1/2 through there real quick. Okay, now the one thing you might be thinking here is, can I have fractions in matrices? Yes, you can. You can have whatever number in the slot there is. Okay, because this is like a, and I forgot to call these before, these are elements. Okay, so that 6 would be an element of this 3 by 2 matrix. You can have a fraction in there, you can have a decimal in there, you can have a variable in there, it doesn't matter. Okay, but right now we're just working with numbers. So we take the 1/2 and multiply it into each piece. Okay, and 1/2 is pretty simple. You just cut the number in half or put a 2 underneath it, and that's a negative, so it'll change our sign. So the first one will be a -3, then be a -5, be a -2, -4, and then here, once we get to that one, it'll be a -3/2, because 3 doesn't cut evenly, and then a -7 for that 14. Okay, put our brackets there, and that's our new matrix. Okay. Not too bad. So hopefully, all the stuff that I've gone through so far has been on that worksheet that you looked at last Friday, if you did. All right, so I want you to look at these 3 problems here, and I want you to try them, okay? You don't have to write them down as you see them. You can kind of just do them on your notes. Just kind of, you can add them in your head and write down your solution. When you write down your solution, I want you to check with the people at your table to see if they are correct, okay? Go ahead. And pause the video if you need to. Okay, on the first one, remember on all of these really, the first thing I said, in order to add and subtract matrices, you have to have the same size. So you need to look at the size of each of the matrices. First one is a 2 by 3. Second one is a 2 by 3. We're good there. Okay, for the second problem here, look at these 2 matrices. They don't look the same. They're not oriented the same. Okay, so remember size is rows by columns again. So this is a 2 by 3. This one is a 3 by 2. So the sizes don't match. They're backwards, okay? So this one, no solution. You can't do it. So sorry if you wasted time trying to do that one. You can't do that one because they don't match. But the other 2, the top and the bottom one, you can do it. So let's do them real quick if you haven't already. So this new matrix it's going to give me, remember, add the corresponding pieces. Okay, so that'd be a -8, and then a 4, -9, that's going to be the right-hand side. That'd be a 15, 6, and then a 7. That's our new matrix for that addition problem, okay? Let's look at the bottom one here. So we are subtracting. Remember the best way to subtract. Add a line, change a sign. Boom, 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 boom. Flip all your signs for that matrix and change it to an addition problem. Much easier to add than it is to subtract, especially when negatives are involved. So then we're going to have a 3, -4, 8, and then a -13. And voila, you're done. Okay? Addition, subtraction, pretty quick. Okay, if you ever need to rewind in the video, please ask the sub, and he or she can do that for you. Okay, so jumping ahead, I want you to try, just do the bottom one here. Do that one real quick. All right, and I said real quick because it should be pretty quick. It's only a 2 by 2 matrix, multiplying everything by 1/2. Okay, which gives us this new one of a 1. Remember, it's 1/2 times each of these. So it's a 1, a 2, a 3, a 4. That's what it works out to be with the scalar multiplication. All right? All right, this one, you got to make sure you write this one down. There is a couple problems like this on your homework, and you kind of got to follow along on how to do it. This is the more complicated side to addition, and we'll have some of these with multiplication as well. All right, it looks terrible. It's not bad. So please write this down, and then we will go. If you need time, pause it, please, and then we'll jump into the example. Okay, so we have to solve for variables in matrices now. Like I said before, you can have matrices or variables in these things, which we do here. We have an x in this one, and then we have a y in that one. Okay? And you kind of got to think of how these are going to work out if you just tried to do what the operations are telling you to. Okay? So that's a scalar there. That's an addition problem there. And then you're saying that it's going to equal this stuff over here on the right. Okay, this stuff. So let's kind of look at the piece that we need. So let's look at the x here. Can we make a little equation using the operations that we have here to see if we can figure out x? Probably. Think about how we add matrices. Well, if I took this matrix here, okay, if I took that one and I added it with that one, then this is what I would have. I would have 5x plus 3 because we had those corresponding areas, right? Okay, so if I did the 5x plus 3, then the next step that would come would be that scalar multiplication out in front. So now it's kind of starting to come together. Hopefully you can kind of see what number I'm going to set it equal to, because where have I stayed consistent in these two matrices? I have this 5x, I have that 3, so then more than likely going to be using that negative 21. And then this stuff right here, that's easy enough that you can solve that. All right, so go ahead and solve for x. Okay, so to solve for x, you distribute that 3 in there. Boom, boom. 15x plus 9 equals negative 21. Move the 9 over. Then we have 15x equals a negative 30. And guess what? X equals a negative 2 because we divide both sides by 15. Okay? Pretty simple. It just looks pretty crazy. So see if you can set it up for y and solve for y. All right, so see if you can get that y. Tell the people at your table what the y value is, and pause the video so they have time to do that. All right, back here, let's set up our equation. We got that 3 out front, scalar multiplication, negative 4 plus a negative y. I'll just write it as it is there. And I can fix it here in a minute. Equals negative 24 because we're going to use these corresponding pieces, right? The bottom right-hand corner. So let's distribute. Boom, boom. Negative 12, and it's minus 3y equals negative 24. Add 12. Negative 3y equals a negative 12. Divide by negative 3, and then you're going to get y equals a 4. And guess what you can do with these numbers that you have? We have an x equals something, and we have a y equals something. You can plug them in to check and see if it works. Okay? So if I put that negative 2 up in here where that 5x is, that would change that to a negative 10. If I do negative 10 plus a 3, that would give me a negative 7 times that scalar. Negative 7 times 3 is, boom, 21. That's how we check it out if we want to see that, okay? Those are the more complicated ones for addition, all right? Hopefully you got that. You set up 2 equations wherever those variables are, okay? On to the next piece. So we'll skip this one just for the sake of time. And I think we have a brain break, okay? So, quick brain break, rock, paper, scissors, math. You guys love this. Everybody gets pretty excited about it. Try not to get too crazy. We'll just keep it basic this time. Do 3 rounds, one-handed addition, 3 rounds, two-handed addition, okay? So remember, you're doing rock, paper, scissors with your one hand, and then you show a number, you add that with your partner's number. Whoever gets the addition problem correct first is the winner of the round, okay? And then the two-handed addition, doing rock, paper, scissors, and then boom, you show 2 hands, so you'll be adding all of your fingers with your partner's fingers. Do 3 rounds of that as well, okay? So pause the video, give them about 2 or 3 minutes to do rock, paper, scissors, math. All right, back to the next thing. So multiplying matrices. Please write these 2 matrices down. We are multiplying, so I'm going to put a little dot in there, like multiplication. Okay, I think you can also call this dot product. That's what they call it for matrices. We're just going to call it multiplication for now. So we have A, B, C, D in one matrix, E, F, G, H in another matrix. All right, it's going to look kind of complicated when I show you the resultant matrix, but remember, we have A, B, C, D, E, F, G, H. If you have the alphabet, just something in starting from A going to whatever, they're just placeholders. So there could be numbers here, all right? Don't make it too complicated. It could just show up as a number, okay? So, after you got those 2 written down, I want you to think how you read the size of a matrix, okay? So at the beginning of the lesson, first thing we looked at, we read the size of a matrix as rows by columns. That's how we're going to multiply 2 matrices as well. We're going to multiply the row of the first one times the column of the second one, all right? So it's going to be these 2 times these 2, okay? So you're going to kind of think of which ones you see first. As we go from left to right, the A is first. As we go from top to bottom, the E is first. So it's going to be A times E, and then B times G, and you're going to add those. All right? So it would look like this when we do multiple steps. Let's see if I can just show that top piece. okay, be A times E, which is this, plus B times G. Okay, so just kind of think of the pieces. I'm taking a row times a column. I multiply the first element in each times each other, and then I multiply the second element of each times each other, and I add those together. Okay, this is matrix multiplication. And then when we look at the second one here, okay, you keep looking at that first row of that first matrix. And then you're kind of like thinking distributed property maybe. So we took this one and we distributed it into this one. After we got that, then we're going to distribute it into this one. So it's kind of go like that. So you just move to the next column of that second one, okay? So then it would be A times F plus B times H. Okay, and then you add those together, which is this. A times F plus B times H. All right, so then you have used the first two, or you've used the columns in that second matrix once. Kind of think what you're going to do next. We've only used one row in that first matrix, so that means we have to bounce down to the second row and do the same thing again. All right, so we go here, multiply these two, add them together. That's our third element, and then we bounce here, multiply these two, add them together. That's our fourth element, so it looks like that. Okay, go back again. If we did this one, it would be CE plus DG, and then that last one would be CF plus D or plus DH. Yep. Okay. This probably looks a little complicated to you. Hopefully, once we do one with numbers, it starts to piece together in your brain. Okay. If you need to pause it so people can finish up writing this down, that's fine. It's more important for us to see it with numbers. I just wanted to see what it looks, or show you guys what it looks like with variables. Okay. So looking at these examples here with numbers. All right, put my little multiplier in there since I didn't have it there. How do we read the size again? Okay. How do you read the size of a matrix? Rows by columns. Okay, that's how we're going to multiply. Rows by columns. All right, it's going to go into this first column. So it would look like this. So we take the first element of each, 1 times 5. And I'm going to write it out in expanded form, I suppose you want to call it, with all the work so you can see it. If you can multiply these things in your head and you can follow your notes, that's fine. All right, so I'm going to take 1 times 5, that's the first one. And then I'm going to take 1 times 9, that's the second one. Oops, sorry, not 1 times 9, I'm going to take 4 times 9. Trying to make sure you guys see where my arrows are. Okay, we did the 1 times 5, then we're going to do the 4 and the 9. Second element of each, okay? Then we bounce to the second column over here. All right, first row, we're still over there. Second column. Trying to make this as visual as possible since I'm doing a video on it. Okay, so it'll be 1 times the negative 7 plus 4 times the 6. So that would be 1 times the negative 7 and 4 times the 6. First element times each other, add them together. Second element times each other, add them together. Oops, I'm getting rid of my work over there. All right, see if you can get the bottom half. So we're just going to kind of go to the next row here. Kind of got bits and pieces floating around. Next row, follow the same pattern. All right, so rows times columns. First element times first element, second element times second element. So 3 times 5 plus a negative 2 times a 9. And then the next column here, 3 times negative 7 plus a negative 2 times 6. Okay, and then I'm just going to simplify that work there. And like I said, you don't have to write out all that work to see what the numbers are going to be. These are pretty easy addition or multiplication problems. You should be able to do them in your head. So this one's 5 and 36. So our first element of the new matrix will be a 41. Okay, this is a -7 plus 24. So that gets me to a 17. And then let's do the bottom piece. So 15 plus a -18. So I'll just do 15 minus 18. So that's -3. And then we got -21 minus 12 or plus a -12. That gets me to a -33. Okay? So 5 and 36 is 41. -7 and 24 is 17. 15 and a -18, that's a -3. And a -21 and a -12 is 33. Okay? That's how we multiply. All right, so now, hopefully you followed that. The second one is a little bit simpler because you only got one row and one column. Okay? But what I didn't explain in the first one is how we can tell if we multiply them, or how we can tell if we can multiply them, okay? When you have two square matrices like that first one, like this is a 2 by 2 and the other one's a 2 by 2, it's pretty simple, you can do it. You can add it, you can multiply it, you can subtract it, whatever, okay? Now the second one here, you're kind of like, well, the sizes don't match, so I can't do it. That was only for addition, okay? We're doing multiplication here. So what you want to do to determine if you can multiply them is you still have to look at the sizes. All right, so let's write out our sizes. This is a 1 row and a 2 column. This is a 2 row and a 1 column. Okay, so they don't match. They're backwards. That's okay. When we look at these, you look at the two inside numbers. So we have these two sizes written out. The inside numbers are both 2's. That means you can do it. Okay, you have to have the inside numbers match. Inside, we'll say size numbers match. That means you can do it. Okay, once you write out the size. And the outside numbers, it's kind of nice. The outside numbers tell me how big my new matrix is going to be. So I got a 1 on the left and a 1 on the right. So that means my new matrix will be 1 by 1. Okay? Which I said you don't see very often because it's just small. And that looks like an absolute value of x. I'm going to make it like a smaller x in there. 1 by 1. It's a 1 by 1 matrix. Okay? So let's multiply this one quick. So we take rows by columns. Rows by columns. So 3 times 5, 15, and then you add it with the -1 times 7. So 15 plus the -7, that's the only operation we can do because we don't have any more columns to move through. That's a positive 8. And that is it. That's a 1 by 1, it's just an 8. Okay, you could end up with something like that every once in a while. Okay, so a couple of multiplication problems. Let's look at another one here. So I want you guys to write these two down. Okay, I want you to write the sizes down, and then I want you to tell other people at your table if you can multiply them or not. Okay, so please pause the video for a minute or so for this so I can write it down and look at them. All right, let's look at our sizes. We got 3 by 2, 2 by 2. Can you multiply it? Yeah, our final matrix is going to be a 3 by 2. All right, that's what's going to be over there. This one, we got a 2 by 2, and then we got a 3 by 2. Can we multiply it? No. The 2 and the 3 do not match. So this one is not possible, no solution. Okay, so really we only have to do one multiplication problem here. You're welcome. All right, so see if you can figure this one out. See if you can multiply it, all right? So I'm going to have the sub pause the video again, see if you can figure it out. Okay, so remember, read the size, rows by column. That's the way you multiply it too. So row by column, I'm going to kind of move through this. So 4 times a -3 will be a -12, and then a 3 times a 1, that's a 3, and this is about the amount of work that I'm going to show on this one. Oh, they're linked together. Let's unlink them here so you can see me move around. Okay, second column, so 4 times 0, 0, 3 times a negative 2. Oops, I'll just do plus a negative 6. All right, so next one, we got to move down. So we used both columns here. So now we move down to the next row, and we do it again. All right, so hopefully you see the pattern now. So 1 times a negative 3, that's a 3, plus a negative 2. And then we move to the next column there. Negative 1 times 0, that's a 0. Negative 2 times negative 2 is 4. Okay, so we're done with that one. Oops. We have to move down to the last row here. Okay, so we got negative 6 plus 0, and then we have, bounce it over there, 0 plus 0. And all we have to do is just kind of simplify that up, and then we'll have our resultant matrix. So 12, 3, double checking my work here, 0, negative 6, 3, negative 2, 0, 4, and then negative 6, 0, 0, 0. Okay, so you can kind of see it's nice when you got zeros floating around in both of those, because then it's just zeros. It's nice. All right, so let's simplify this. We get a negative 9, a negative 6, a 1, a 4, a negative 6, and a 0. What is the size of this matrix? We have 1, 2, 3 rows, 1, 2 columns. That's what we said we were going to have when we're done. Okay, so that guy right there is our answer. Looks like I can't move the arrows out of the way. Okay, that's our resultant matrix. Okay. If you don't get it yet, so let's look at this first one here quick. We'll just do one more multiplication problem if you need it. Okay, rows by columns, these are both square matrices. So boom, boom. Do them real quick, so you can kind of see that once you get the pattern, you can start to do them a little faster. So we got 8, 9, that's 17. Okay, I'm just going to kind of do the rest of them. So then 6, 6, 12. Do the other piece. 16, 9, 25, and then the last two, 12, 6, 18. That's your matrix. So that was pretty quick. Hopefully you can start to see the pattern. It's rows by columns here. All right, and it kind of starts to look messy when I start to add a lot of lines and arrows, so that's why I haven't been doing it a ton. So the last problem I want to look at, this guy right here. So just like that last problem of the addition with the variables in here, I want you to write this thing down. The sub can please pause it so you guys have time to write it down before I start it. Okay, so hopefully you kind of looked at it and thought about how you would do it. It's not as simple as just picking a corresponding area and making an equation, or corresponding part of a matrix and making an equation. Okay, a corresponding element, I guess. Think about what would happen if we just did multiplication, just kind of started it out. Because this, when they're crunched together like this is really multiplication. So you take rows by columns, all right? Let's see. If we did rows by columns, which number in my resulting matrix, okay, that's this guy over here, which number should that give me? Well, we took our first row here and our first column here. If I multiply all that stuff and add it together, that should give us our first element in the last matrix, or in our resultant matrix. So let's see if we can make an equation from that. Okay, so try to draw some arrows and stuff on here, see if we can get it. So we take first element, negative 2 times a 1. Second element, 1 times an x, so that's just plus x. Remember, we're multiplying these and adding them. And then the third element, 2 times 3, that's a 6. And we can have multiple like this. And then I said before, since we did the first row and the first column, that's going to give us the first number of our resultant matrix, which is that 6. Now you got something that is simple enough to solve, and it's actually super easy to solve, right? So combine like terms, you get x plus 4 equals 6. Move the 4 over. X equals 2. All right. Now, can I use that again? So let's see. If I said that I did the first row and first column to get me that 6 up here, what do you think I'm going to do to get that y in the bottom? Since it's the third element over there, I'm probably going to have to use the last row and then this column again, because it's the only column there. And then that should give me the y. All right, so let's set it up. We got 0 times 1, that's a 0. We got the next one, negative 2. All right, so negative 2 times x, that's negative 2x. And then 4 times 3, that's a 12. And we said that that should give us our last element of that resultant matrix. And you're like, well, what am I going to do now, teacher? Because I got an x and a y floating around. Well, we have an x that we found over here. That can go right there. So plug in the x value. And really, we could have put the x value up here if we wanted to. Doesn't matter. There aren't very many variables floating around. So plug it in somewhere, and then solve for y. All right, so negative 2 times a2 is a negative 4 plus a 12, that's an 8. We get y equals 8. Did we find all the variables? Sure did. That's all we have to do, okay? That's the way it works with multiplication. You kind of have to think forward in your brain, which row and column am I going to use to get the piece of the resulting matrix that I want. In this case, it was our y down there. Okay? So, that is all. We're not going to take time to go through this word problem. There's some word problems on that homework. Give them a try. If you have questions, you can let me know. But we're not going to take time to go through this one. So here is your assignment. Write it down somewhere on a piece of notebook paper. I have the old sheets, or I have they're not really worksheets. I took pictures of the old book. They're in Google Classroom, okay? Those correspond with these problem sets. All right, so you're going to write these numbers down. You're going to get on your Chromebook, which you should have had it away the whole lesson. Okay, now you can be on it. You're going to go to Google Classroom, and you're going to look for the page 191 and the page 199. Okay, I will have those in Google Classroom. You're going to use those 2 pages to do the homework. Okay, one of them will be addition and subtraction of matrices. The other one will be multiplication of matrices. So hopefully this made sense. I sent the link to everybody in, it's in Google Classroom if you want to watch it or go back and look at some of the examples. But hopefully this made sense to you. If you got questions, let me know. Have a good rest of your day.